So it's time to get started. So today's tasks are to write get our two different removes, see if there's anything left in the interface that we have not written. And if we get through all of that, we can start writing and talking about what an iterator is and why we care to write one. And then we are going to write. Any questions about that? Plans for the day? I'm going to choose right here. And if I'm doing this professionally, I'm writing documentation for each of these methods as I'm writing them. To avoid taking too much time, I'm just diving right into the code. I would also recommend, if this is you, testing this program after every time you complete a method. But since I have tested this before, I'm going to test it once at the very end, make sure everything is working, make sure I didn't make any mistakes and go find anything that I did. But if I'm being a good programmer, I am testing this after every method completion and writing pretty rigorous tests to make sure that it's working to the extent that I think that it is. All right, so let's go ahead and write get. So we know from the interface that we should write, it's going to return something of the generic type. Get is going to take a parameter, the index of the node that we want to return the value of. We also are going to throw, what did we say that was going to be?
A legal argument.
A legal argument. All right. So let's go ahead and figure out what the illegal argument exception would be. Actually, do I want to say an illegal argument? This might make sense where an index out of bounds would make sense, because we are going to, we'll see. I'll write them both in. So there are multiple different values that might cause you to want to respond with a different message here to the end user. So maybe we would want to differentiate between the index being out of bounds versus the list being empty. You're trying to get something when the list is empty, rather than saying the past index is out of bounds. That forces the user to interpret the fact that, well, I passed in 0. What does that mean? You could instead just return the fact that the list is empty, and it goes, oh, of course, you can't get something when the list is empty. So let's go ahead and just say if the index is less than 0, or the index is greater than or equal to the size. That makes sense, right? We don't want to say size -1 here, because if we grab the size, that's going to be the first index that is out of bounds. We go from 0, that's the first legal value, up to size -1, that is the last legal value. Yeah.
When we just want index greater than size.
So let's say we're trying to identify a particular index at the list. If we're going to get the value at index 0, let's say we have 3 elements in the list. The size is 3. That means there's going to be something at index 0 and 1 and 2. But there's nothing at 3. If there were something at 3, we want to make sure that we return it. But since that is the first thing that is out of bounds, then we would want to make sure that if index is equal to the size, that is the first element that is out of bounds. That is a very common off-by-1 error that I would expect to see. If that is the case, we're going to throw that illegal argument exception. And we would say something like past index is out of bounds. Great. I'm going to write a second one. We don't need to use an else if here, we can straight up use an if, because again, if you throw an exception, that immediately terminates that method. You could use an else if, but it would be, there's no actual difference here, so I'm going to just write it as an if. And we can just call is empty here. If the list is empty, then we can throw another one. Throw a legal argument exception that says the list is empty. With the exceptions out of the way, now we can actually dive into the logic of the code. And I would argue this is one of the simplest methods to write because of how we've set everything else up. You all took a stab at this. What did you come up with? What's the first thing that I should do? Yeah, we want to return a node, but that node already exists in the list. So we probably just need to find a way to get to the node that is the node we want to return. Yeah.
I first I wrote an if statement for a table, like index equals 0 so that they can return that head.
Okay.
And then I wrote a node. Actually, that makes sense. Okay, I wrote a node where current equals head, and then I did for loop.
All right, so we'll say if the index is 0, then we want to return the head.
Head dot data.
Yeah, because we're returning a t, so we want to make sure that we return head dot data. That makes a lot of sense. Great.
The return find node before index -1.
Yeah, you could do something like that. So we want to find the node before the index. What if is that going to work in general for something at the end of the list? There was a special case here for the beginning of the list.
I was moving on dot next.
Gotcha, okay. Let's write the base case and we'll see if there's a need for a particular special case. So to get at that general case, we need to identify a singly linked node, and that we're going to call, I guess, we'll call it the current node. And we can reuse the method that we already wrote, find node before. It's going to access the node before the node that we care about. So we are going to do that. We're just going to say, this is going to be find the node before, and we're going to pass it the query index. Then we're basically done, right? We have the node before the one we care about, so we just need to access the next. What if the index is the size -1? Is there going to be a next? Because we want to, let's write it out. We're going to return cur.next.data. Is there any chance that cur.next is null? Yeah. Yeah. Additionally, if we're doing this find node before, we're going all the way through the list. We should, rather than looping through the entire length of the list, if they're trying to access the last element, we have a direct access to that. We call that a tail. Rather than go through node by node by node by node, if we have direct access to the end of the list and they're trying to query the end of the list, we should just jump there and avoid going through that looping process. Yeah.
So I agree, especially if the longer list, doing just a call straight to the tail first, if you happen to be the size -1 already.
Yeah.
But wouldn't this still work if you just said, assuming you didn't care about it being faster, didn't you just say return find node before index.next.data? It's you have a list size 3.
Yeah.
You're calling for element 2, so element 2, which is the last one on the list, and you say find node before, then the element 1. And then that .next.data is 2, and that's in the
It is
list.
exactly what we want. Yeah, so this will work. You're absolutely right. This will work even if it is the tail. So this special case that we're identifying has nothing to do with the actual functionality of compiling and working. But it does save us a little bit of time in one special case. Is that worth doing? Maybe if your list is of size 1 million, it saves a few milliseconds. In the end, it's probably not hugely important, but I like to incorporate that when I can. So we're gonna say if index is the size -1, then we are going to return tail.data. And that is that special case. Question?
So when we were writing final before, we decided to do index greater than size, not greater than equal to.
Yes.
So we were going that, like, why we written it there, we were gonna add it to the tail end. That would mean if you put in index 3, it's gonna go to 2, and then when you do that, it goes to 3, but 3 doesn't exist yet.
Right. In this case, we're only allowing for an index that is already in bounds. When we wrote the add, we were thinking about a node that we were going to be adding at the end.
Right.
And because of that, that's the difference between this being legal and we want to do greater than or equal to, because we have to choose something and only look at that element in the list. Versus add, we could identify a position that is currently out of bounds, but won't be once we finish adding that node at the end. Great points. Yeah.
Dot data.
Sorry?
Dot data, that's the.
That is, yeah, so back in our singly linked node. We have 2 different fields. So we're just using a public access to these. We should honestly probably, now that we've done this. Make them protected. If we do this, then this public call to the data is legal. Because we are within the same package. So we can do a direct access with this .data. But outside of this, we have no way of seeing what a particular node's value is. We haven't written any getters, we haven't written any setters. You may have heard of them as accessors and mutators. We haven't written them, so they're just straight up inaccessible outside of that, which is fine. There's no reason that anyone outside should ever need to know what the value of a particular node is unless it is returned to them from this value. Any argument to that? Any reason we think this should be public? For data or for next?
Can't really ever think of a reason for the user to need to.
So for our singly linked list, if anything we're ever returning is a node. We return a value here, that's fine, that makes it public. We're doing the access here and then passing it back to the user. That makes it public to the user. But the only way they can see it is by interfacing with methods that we wrote. They can't come up with their own code to access the values of nodes in this structure, which is probably good for encapsulation. If this is something like grades, maybe we would want to surround this entire code with some kind of login system that says you can only log in and call methods based on your own grades, not your classmates' grades. Something of the sort. In general, when you care about privacy, it becomes very important what your access modifiers are. If the rest of your program needs access to it, have intelligent package structures such that you use the protected keyword, it's public to the rest of your program that needs to access it to do what you need it to do, but it's private from someone who wants to write code that now queries and accesses this data. This is how you get security vulnerabilities in your data, in your code. Questions on that? Yeah,
Does it matter that the thing you just wrote index was size -1? Does it matter that that's below the flying node before? I don't know.
yes, it should actually be above it. Great point. I meant to write it above and then I did not. This is meant to save us time. This is what wastes time. You don't want to do all of that work and then fail to use the work when it's done. Great point. I love how aware everyone here is. If I make a mistake like that, I want to be called out on it, because there is a reason, there's a reason that we want to write it the way that we're going to write it. Everyone should be seeing the way that is correct. So if you see something like that, please don't hesitate to raise your hand. Even if for some reason you're not right, I would rather explain it. You're probably not the only person with that confusion.
Is there any reason why you have to use a size method instead of just
Oh, you can absolutely use size here. If I just replace this with size, it becomes the field. I could say this dot size. Any one of those would be correct. I use the size method because we wrote it. Any of them would reasonably be correct. Size is mostly meant to be called from the outside perspective, so it's probably actually more efficient to write size, but we're talking about a very few number of CPU cycles for this. So it's probably not particularly important which one we use, but all three are perfectly reasonable. Great point as well. I'll leave it like this. Why not? I generally like to be consistent. Consistency adds to readability, leads to less confusion, but I will leave it like this just so you know it's an option. All right, next we're going to, if there are no further questions, dive into the overloaded remove. Writing two different removes, we're going to be able to remove at the end and remove in the middle. So let's start with removing at a particular index. What did we decide here? That we're going to have a legal argument. How are we going to think about remove? I guess we can start with the exceptions, but while we're writing that, maybe we can start thinking about what are the cases to a remove. There might be some special cases here we might want to consider. Yeah, the list is empty and we try to remove from it. That is certainly an interesting issue. So let's go ahead and write that one. If we can call is empty. We could also here write size equals 0. We could write quite a few ways we could do this, but we'll call is empty. If is empty returns true, then we want to throw an illegal argument exception. And we will say that the can't remove from an empty list. Great. What other ways could we get this illegal argument exception? Yeah,
Not just do 2 and 1 and just being, if index less than 0, index greater than size.
yeah.
Like, would that do the same thing as is empty?
So is empty is just checking for size is 0.
Okay.
On the other hand, if the index is out of bounds, then we want to make sure that we say something that is different. The reason we don't do them all in the same place is the actual communication we want to give to the end user is different.
Or more, I guess what I mean is, would it not be easier to just have, like, since if size is 0, that means that the list is empty already. So
right,
you have it if size is less than or equal to 0, or index is greater than size, and it's.
yeah, those are all of the error cases, but I think when the list is empty, we wanna communicate that the list is empty.
Yeah.
When the index passes out of bounds, which it is when it's 0, but letting the user know just a little bit more, the list is currently empty. I wouldn't mark it wrong if you put all of those together. If you submitted something, I don't think it is perfectly wrong. I just think that whenever you can communicate different things to the user, that helps. Yeah, yes, so that is a good point, right? So if is empty can't be called for some reason, then maybe we do want to do something before this. Anyone else see any issues that we could have here that would cause us to actually crash? Does that make sense? Can you explain that in just a little bit more detail? I think that would be useful for the rest of the class, yeah.
So does it mean like if it's empty, it's not actually implemented, then it can't actually do it, or?
That would be something, so Java doesn't care about method order. If you're in C or C++, then you need to define a method before you use it. There are two ways you can do this. If you write a header file, then it doesn't matter the order of implementation because it's defined in the header file. If you don't have a header file, then the method order, you need to define a method before you call it. Luckily, Java parses the whole file ahead of time. It is less efficient to do that, but it means that you get fewer bugs as a programmer. So that's a language design decision. And as you go further and further in the curriculum, you will eventually see some use cases for how languages are constructed, why languages were designed the way they are. There are always use cases. These languages prioritize different aspects of the programmatic experience. And Java is mostly a user-friendly, pretty darn slow language. It's programmer-friendly language. Its main use case is that, why not? I'll pick the quick aside to talk about it. It gets compiled into what is called bytecode. And bytecode is its own language that is platform independent. From that intermediary bytecode, there are programs that are written to turn that bytecode into executable code on Windows architecture, on Mac architecture, so depending on the actual architecture of the machine you're running it on, that becomes the intermediary step. In many other languages, there's a compiler, you call that compiler and it goes straight from the code that you wrote directly to the target. But then you have to use a separate program for each of those, not follow the same process to get to that intermediate step. Sometimes that intermediate step is an assembly language, but Java has its own bytecode. So the other one of these that we were going to write is about the index. If the index is, let's see, what makes sense here? We want to do anything else other than just straight up less than 0 or greater than or equal to size. I don't think so. Well, we want to stay. There's always my cursor. There we go. Is there any reason to care about the order of these?
We probably want to know if it's empty before we actually look at anything else.
Based on the implementation of is empty, it's going to check whether size is 0. Is there anything where that would potentially break for any reason? Do we want this to come before that for some reason. What about this? Yeah, so we're calling size here.
Or index. But yeah, because if you have the first one there, you just. All. Because 0 would be a legal index. If it's size 0, then you can go through with the argument.
Yeah, that is an interesting point, huh? If size is 0. Then if we do this, then we might want to just remove at 0. So if we check if it's empty first, that means that 0 is not a legal index to remove. So do we want to say size -1? What's the solution to this?
You get with equal.
So the basic idea is we're passing in 0 as the index we want to remove. If size is 0, we're catching it here that says that we can't remove from an empty list before we would say the past index is out of bounds.
So you just want to propose?
Yeah. It's exactly what we want to do. We're going to check this before we check that. Okay. We good? Moving on? All right. Anything else we want to check before we dive into logic? I think we're good to dive into logic. So what are our cases? So we need to check if we're trying to remove the head. Is that going to be the same as removing any other aspect of the list? That's a different case. Why is it a different case? Say here, yeah.
We have to reassign the head node.
Yeah, we do have to reassign the head. If it's in the middle, though, there's something else, yeah.
It's the find node before.
Can't use find node before, because we want, in general, we want to redirect the next reference from the previous node past the node that we're trying to remove. If it's the head, there is no node that comes before it. So we need to identify those two different cases. So we can say if the index is going to point at the head, which would mean that it is 0. So this is identifying the case that we've passed these two if statements. So we know the list isn't empty and the index isn't out of bounds. So now if the index is the first element of the list, we want to. The first thing we need to notice is we're trying to return here the value of the removed node. So before we make that node inaccessible, we should probably store off the value of that node. So we're going to say some value, we'll call it data. We're going to assign it to be head.data. Since in this case, we know we are referring to the head. So we're storing off what we eventually need to return at the end of the method. Is there a nice, easy way from here to remove this node? We say here, yeah.
Like you make type dot next.
That is super easy and I love it. Head equals head dot next. This just points head to be the next node in the list. The entire reason head, that node was accessible is because we had a head reference. Let's actually take a look at this, why this works and why the Java garbage collector is just going to eat that node. So we have a very small, it doesn't even need to be larger than 2. I'm just going to say this goes off to nothing. It doesn't really matter if this is a null pointer, if it goes off to more. This is our head. When we say head equals head dot next, I'm actually going to rewrite this to be slightly clearer. This is our reference variable that is pointing at this node. When we say head, where this points, could point to where it currently points dot next. It's gonna redirect this arrow to point here instead of here. Before, we could access this node by going through this chain of calls. Now there is no way to access this node. There is no legal reference to access this node's data or this node's next. Because there is no local way to do that, the garbage collector is free to eat it. So it will go do that. And we've done the equivalent of deleting the first node in the list. So that's why something as simple as this works. And doesn't lead to a memory leak. So all we have to do now that we're done, let's actually query this. What do we have to do? Yeah, we changed the size of the list. We removed something, so we should decrement it. Last thing we should do, return. And this is now the data at the node that got removed, which was the entire purpose of this. Great. So that is the special case of removing at the beginning of the list, when there is no prior node to go redirect. Let's draw out what happens in the base case. Let's talk it through. In general, what are we doing? Yeah.
Want to check for indexes to tail?
Okay, we can check if the index is the tail, because that's going to change things a little bit. There's no next to go refer to.
Right.
Yeah, so I would argue we can build this into the default case, but it is something that we are certainly going to want to think about at that stage.
I was gonna say like in cases, so if we have like a list that's like a million, like you say.
Yeah.
Does it go through?
It doesn't go through the entire thing. We could just say, if we're trying to delete the tail. Yeah, I actually buy that. We'll make a separate case for it. If index is size -1. That is removing at the end. What do we want to do?
You have to store the data.
Yeah, we would need to be able to say that the new tail is the current tails dot previous. We have to call get node before. Even in the tails case, there's no way to refer to the node before the tail to be able to reassign the tail. So I think it has to be built into the else. That's a great point though, and it's worth actually thinking through and starting to design, because you run into that logic and you go, oh, I think this is going to be the default case. So in the else, yeah, question?
So if we remove the tail, we have to do the same thing we do with the head, where we store its data so that when it's gone, we still have it.
Yeah, we will certainly need to,
Like, we probably do that like every.
yeah, for every node, we'll need to be able to remove the value of whatever got removed. Because that is how we've set up our method, and it would be very useful to an end user to say, we deleted this and here is the value of what we deleted. It's a nice peace of mind to the user to say, did you delete the right thing? All right, I trust you. I can't see your code, but I can now look at the value of what you deleted. It's what I expected. I will continue to use your application because it continues to do what I think you're doing. All right, so I think the first thing we want to do is actually call find node before. So let's do it. We're going to make a singly linked node type T. We're not actually instantiating it. We're just making a named reference variable. And we are going to, what are we going to call this? What makes sense? Current?
I like to use temp, but I don't know.
I'm actually going to use prev. And because this is the node before what we were trying to remove, it gives us a little bit of a, all of those would be okay. Temp works if it's something that doesn't really need to be considered throughout the rest of, but if there's something specific that we can use, then that helps me to be able to see what does this variable represent. So we're going to call find node before, and we're going to pass it the index. That's exactly what we want. After this, we are free now to store the data because we have an easy way to access the node that we care about. so let's go ahead and write to data. We can say this is going to be Prev, the only node we have access to at this point, dot next. That's going to give us the node we want to remove, dot data. That's going to give us the value that's stored in the node after the node before the one we want to remove. Unnecessary complicated way of saying that, but that's exactly what's in the line of code there. I think that helps to make that a little bit clearer. How do we remove the node that we want to remove now? Question? Yeah. If this is the end, so now we need to start to think about if we are at the tail or if we are not, as we start thinking about that. But I would argue that we may even be able to fit that into a generic line that works for the tail and works for the middle. Yeah,
So you would do prev.next equals prev.next.next.
let's think about that for a second. I'm actually gonna write it. Prev.next equals prev.next.next. Think about this for a second. We have a very small list. If we want to delete this node, this is our query node, we want to get rid of that. This is what's going to be identified as prev. If we say prev.next equals, we're going to say we want to modify this arrow. Prev.next, this node's next reference, we're going to set that to prev.next.next. What is this value of that dot next? Null. It's not an error, it's null, which is exactly what we want. We want this to now become null. If that is the case, there is now no way to refer to this node, so the Java garbage collector is going to come eat it. So this ends up being exactly what we want in the middle of the list and at the end of the list. Let's go through, so that's the end of the list case. Let's say this actually goes to one more node, so that we're deleting in the middle, just so we can see that it works in the middle. Prev.next, we're going to redirect this arrow to be prev.next.next, whatever this is pointing to. So this arrow, instead of pointing at this node, is now going to point at that node. Which is exactly what we want. We're getting rid of this node in the middle. Since there's no direct access to this node, the Java garbage collector will come eat that node and get rid of it. So in both cases, this works. Question?
Say that you did want to actually have a little bit more control over whether or not it deletes, like, things that aren't being used, like how you have to free something and see, right?
Yeah,
Is that ever useful in Java, or is it more or less?
not so much in Java. In other languages where you have to do manual memory management, there's no garbage collector, then it becomes much more important and you have a lot more thinking to do.
Yeah.
This is a much more complicated procedure in a language like C++.
Yeah.
But Java makes it very easy. You don't have to worry about memory as long as you're thinking, is there a way to reference this? If no, it's gone. I don't have to do anything else. Yeah.
Wouldn't you want to know if it was at the end so you could reassign tail?
Yes, I will argue that we can figure that out and reassign the tail based on the index. So that is exactly what we're going to do. There is still something to do with regards to the tail, but it has nothing to do with this precise line working or not working. But that is an excellent point. So the next thing we're going to do, as soon as we are done with this, we need to identify, did we remove the tail? Do we need to reassign the tail? So we can say, if the index that we tried to remove, so notice we haven't modified the size yet. We've deleted a node, but we haven't modified the size. So we can say, if the index is size -1, then we can say that tail is the node we identified prev before the one that we wanted to remove. We still have a reference to that node before the node that we removed that was at the end of the list. If we remove the one at the end of the list. Does that make sense? Do people have any questions about that? Yeah,
I'm a little confused on the size -1, like. So they're just kind of on the user to make sure that they don't enter the exact size of the list, they have to do. They have to do max whatever the size of the list is -1. Like, and I know, yeah, okay, so it's just on the user to make sure that.
if the user does that, note that this exception. Isn't necessarily going to crash the entire program. It's something that if you were writing a program that did that, you could surround it with a try catch. Since in your documentation for this, you would say, you would state that this method can throw an illegal argument exception. If that is the case, and there's any reason that you're using this list and you're writing your own implementation of something that uses it, if you call a method that can throw an illegal argument exception, you should surround it with a try catch and catch that illegal argument exception. Now it's on the user to either let their program crash or come up with the logic that says, when you see this and it says past index is out of bounds, you go, what did I do? Oh, I did the wrong thing. If it was a bug the user did. Or they could try to recover from it in the middle of their program. They would write a loop that try catch would be in between. It would say basically go back to the beginning of that try. We're going to try it again, maybe get something new from the user of that program to try to grab an index that is in bounds. But as far as the list is concerned, that's not something we have to handle. That's going to depend on the end user's use case for this list. Great question. Yeah.
Is there any reason we didn't decrement the size and then just check?
We could do that, because what we're gonna do at the very end of this is we still need to decrement the size. So if you were going to put this size before this if statement, then you would have to check if index is equal to size by itself. You could do that, but it is something that you would have to recognize that is the associated change. I find this to be a little bit clearer myself personally, but I'm also open to the fact that that's just me. Maybe when you write it, it's clearer in some other way. It is perfectly correct if you made this size minus minus come before the if and then checked if index was equal to size and not size minus 1. All we have to do now is, again, return data. Since we notice we have some copy and pasted return data and return data, we could factor this out. Let's go ahead and do it. We don't return data here and there. We return data here. Why doesn't this work?
Because data's not in the main.
Right. How could we fix this? So we could return the data here. Yes. So if we do this. And then inside, since they're separate values, say data equals. Now we can return the value of that data. One thing you have to be careful of if you're going to do this is to make sure that data actually has a value through both of these paths in the if and the else. Otherwise, you may be returning null. Because this data, when you assign it to be nothing here, is null. Yeah.
It still works the other way, because there's only one way to find data, or sorry, create an instance of data once instead of multiple times.
Yes, so it would absolutely work the other way as well. Just wanted to go through both of these are equivalent. And depending on what you see as simpler or less confusing, you're welcome to do either way.
What did the IDE flag it then?
It flagged it because data didn't exist outside of this. There's nothing that the compiler knows as it reaches this. If we did T data here and T data here, even though this is an if and an else, we have to go through one or the other. When the compiler hits this, it doesn't know for sure that this data has a value by the time it reaches the end of the if and or the end of the else.
But it still works.
It would, so it won't compile for that reason. The code will not be able to run based on how the compiler is written. That's only going to be true and legal if data will always have a value. If that's not the case, then the issue is, we don't know if data is even declared. It may not be possible to return if you wrote it in such a way that, like for instance, if this line were commented out, it doesn't know the difference when it reaches this point. Imagine that we hit the else, we go through this, and at the end of the else, we want to return a data. Data hasn't been declared, it's not a local variable in this case. In that particular run through this method, where we skip over the if, go to the else, there's no data. The compiler can't easily check whether there is a data in all possible cases for every possible run of this program. It only knows about the existing run of the program. It turns out that, and if you want the answer to this, you'll have to take compilers from me. I'll go into the level of detail that you need to know that that's actually a question that we can't answer. It is not computationally possible to answer that question that says, for every instance of this program running, is there going to be a legal data when we hit this return? It's a great question though, and it's a 400 level answer.
All right.
That's great. Question.
The size of, like, before the return statement.
Yeah, we could also factor out the size minus minus if we did that. Since there's no way we get to the rest of this code without needing to decrement the size. Sure enough. So let's go ahead and do that for efficiency's sake. If we're gonna go through the chain of refactoring and making data appear ahead of this. Then we might as well factor out everything that we can factor out. I like it. Shorter program. Questions or concerns on anything that we've talked about or implemented with remove in the middle? All right, we have just a couple of minutes. Let's get started with the, actually, one thing I can do is go add an at override above this that I forgot to do. Again, it doesn't affect compilation, but just for clarity, show that we are implementing something from the interface. Let's go ahead and at least write the remove an element. This says we're going to go find the first position where this element appears, and we're going to remove the node that is storing that value. We said this throws, we say a null pointer? I think we said a null pointer.
Yeah, there's.
What is that null pointer exception?
Element as well.
Yeah, if element is null, then we want to throw a new null pointer exception saying something like great. Any other issues we could run into if we try to remove a particular element that we could catch right away very easily?
Element is not unless.
We would have to probably look through the list to figure that out. That's gonna be the process that we're gonna have to go through. What would be an easy case where we know, why are we even gonna try to look at the list? List is empty. Yeah, that's exactly right. So we're going to go ahead and start packing up. If you have somewhere you need to be, we'll just say it is empty. Then we can throw new. This is certainly not a null pointer exception. So I think we actually want an extra, let's call this an index out of bounds exception. We'll stop there. I'll go back to my, did I say that here? Remove T, no pointer exception. Index out of bounds exception. All right, we'll stop there. We will come back on Monday. I think we can get through this, everything else, at least start talking about iterators. And at that point, I'm unsure whether I'll throw up the first assignment and let you start thinking about it over the weekend. I will probably do something like that without the expectation that people get terribly far with it. I won't be able to do this Wednesday. It's probably looking to be next Wednesday, a week from Wednesday that's going to be due. But I would recommend getting started whenever you feel comfortable getting started, sooner rather than later. Have a great weekend. I have office hours starting now. If you have any questions?